Good afternoon, everyone. Welcome to today's presentation, sponsored by CO Aftermarket Products.
CO Aftermarket Products engineers and manufactures Toledo Transkit, the most trusted and complete kits in the industry for 25 years. Toledo Transkit gives you more critical components, more OE components, like premium seals and gaskets, more design enhancements, patented components, and all the little extras you won't find elsewhere. At CO Aftermarket Products, we don't just make kits, we make kits better. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit. Like re-engineered valve body gaskets, preventing EPC damage by eliminating the shredding you get from original equipment. Plus, all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. When servicing Honda and ATRA transmissions, shaft nuts are quite often damaged during removal. Toledo Transkit provides all the main shaft, secondary shaft, and counter shaft nuts, so you don't have to try to reuse the originals or pay extra for them at the dealer. Honda Acura kits also include valve body screen filters, pressure tap washers, and other important components like bolt locks, roll pins, and pistons. What you get is a complete kit with great fit and no wasted time or worry about ordering extra parts. If you want the best sealing transmission kit in the industry, ask for Toledo Transkit by name.
Okay, if you have any questions or comments, please send your emails to webinars@atra.com. Any questions you may have during the webinar, feel free to text them to me, and I will try to answer them the best that I can. Next webinar coming up will be on the Lineartronic Gen 1 and Gen 2 comparison. Some real late information on a different tool for the Gen 2 that has to be used to disassemble it. We had to just come across some of the information for that. See you in Paris, of course, at the Paris Hotel at Las Vegas, October 27th to the 30th. That's when we'll be holding the ATRA Expo. All right, today's presentation, we're going to be talking about the internal components on the 68RC, the 6-speed. We're going to cover a lot of the updates and parts changes that have come across, especially on the newest unit that just come out. There was a change in the input shaft and stator on the 2011 68RC, as well as another transmission added right about at the same time. Now, as promised in the first introduction webinar, we mentioned the input and stator shaft changes, and we cover more information in this webinar. Now, the new transmission is much smaller in many ways, but it's larger in one way while identical in design. The new unit is designated the A460. We have not seen that in Dodge yet. Dodge also added an AS66RC, which is derived from the AS69RC, same ratios, but it goes behind the smaller 6.4-liter gas engine. This all came about in about 2014, and I haven't been able to get my hands on that unit yet. So we have the smallest unit, the 460, and then we have the 465, and then of course the AS68RC, which is found mostly in the Dodge, with the input and stator shaft design change in 2011. Now, of course, this does not include the very similar but much larger AS69RC, with many differences that we covered in the introduction webinar. Now, all this following information will reveal some of the changes we've found so far. Now, there may be others that we haven't seen. Now, if you have information to add or experience anything different, please send me an email just to let me know. Okay, on the Dodge applications with the 68RC, and of course some of the Cruiser vehicles will have a longer input shaft with smaller ring lands from about 2007 to 2010. Now in 2011 and 12, the ring lands on the 68RC input shaft became larger, and they're the same as what the A460 has, which is the smallest unit. That's where the smallest, but still it's much larger than some of the other 68s that we've seen in that area. Now, there's only one converter part number for Dodge. Isuzu does have two part numbers for the converter. Now, in about 2013, Dodge went with a much larger AS69RC unit. So you can see here that we have three shafts on all three units that could be basically the same thickness. Now, the internal ring land on the smallest unit, the A460, is a little bit larger than the other two. Again, this was until about 2011 to 12 when Dodge on the AS68RC went to the same size ring land as you see here. The shaft lengths are a little bit different also. The shaft lengths on the smaller unit and the unit, the 465, about the same. And then again, like I said before, right around 2011 and 12, shaft became a little bit longer when they went to the larger input shaft lengths. Now, on all the Dodge and some of the Cruiser vehicles, when we start to look at the stator shaft itself, you're going to see double rows of splines on the longer shaft. So looking at the differences between the stator splines and length, we measured from the front to the rear, obviously from the case, from the actual bench all the way up to the tip, on all three types. Now, you'll notice the worm track's a little bit different here on the 460. The length of the shaft is about the same until obviously 2011 and 12 when we went to the longer input shaft. Obviously the stator shaft had to change also. Now the 460s always had the wider bore. You'll notice two rows of splines here on the stator support shaft. The lower row is a little bit shorter. Over here we have a single row of splines, although some of them are actually missing at the top. Then the wider bore in 2011 and 12, this has a full double row of splines with a little bit shorter row at the top. Looking at all three pump types, you can easily see the 460 is slightly smaller, but it's similar to the 465 and the AS68RC found in the Dodge. Now looking at all three pump types from the stator side, you can see the 460 has an added plate not found on the 465, which would be Isuzu or Fuso, and the AS68RC, which is what it's called when it's found in Dodge. Now the valves in the stator ring size are the same on all three types, but obviously the stator bore is larger on the 460. Again, same thing with the 2011 and 12 AS68RC. So we checked out this added circuit. We followed the hydraulic circuit all the way through the case. It's actually designed to connect the secondary regulator valve oil circuit through a 38 thousandths hole in the plate to the lube dam on the front planer. Now the front planer is turning when the PTO gear is operating in park with lockup converter clutch apply. So the pump body is going to look a little bit different, obviously, because of the worm tracks of the added circuit we just mentioned. So what happens if we install the smaller rings on the larger shaft? After all, there's a difference of about 50 thousandths in size. Basically what you'll end up with is a PO796, normally right after you put it in gear or as you take off. This is indicating a problem with pressure solenoid C, or otherwise called linear solenoid 3. Now, the linear solenoid controls the supply pressure to the clutch, which obviously in this case would be the K1 clutch. Now, the TCM verifies the operation by monitoring the pressure switch 7. So this is why we're getting these codes. all the computer knows is that it didn't see what it liked on pressure switch 7, so it's thinking that there may be a problem with solenoid C that it could be causing this pressure issue. Obviously, once the fault is detected, it will go into limp mode, converter clutch will be disabled. Now, the limp mode gear will vary based on how fast and the road conditions that you're going at. Then the new light will come on, code will be set. We mentioned all this information in our 2015 ATRA seminar. So let's take a look at the lower valve body. All the valve bodies are basically the same. There'll be slight differences in size, and obviously the spring dimensions will vary from model to model. One of the things I want to point out here is look at the cooler check valve. It's about 12.7 millimeters. And the same thing with the little base capsule that holds the spring for the ball. That's at about 0.667 thousandths. The one over the upper right is the same in this section of the valve body, and there's no check ball here. There are no small parts or check balls found in the cover that goes over that section. Now, there's several accumulators and one check valve located in the lower valve body, obviously on the other side. There are no check ball found in any section of the valve body other than the orifice relief check balls. Now, notice the difference in size of the orifice ball here for the D ranges. It's a little bit smaller than the previous one. This was 10 millimeters. Same thing with the capsule. You'll see the capsule is a little bit smaller also. So we have two more check ball orifices here. They're both the same size. They're about 10 millimeter. But notice the difference in the one found inside the valve body right here. This one's 11 millimeters. So its actual ball size is a little bit different than the others. We have a small filter or screen. It goes in just the way you see it. The open end must face up. Now, there's a pretty large drain ball located here in the upper section of the valve body. This thing's 27 millimeters. It's pretty big. So let's look at the primary and secondary reg valves. These are both found in the pump stator or the pump cover. We have all the spring dimensions in the handout. Again, this is the only thing that's going to change here would obviously be on the 460. The valves, I didn't actually measure them, but the valve springs are a little bit different in size for the smaller unit. So looking at the pump assembly, obviously we have a thrust washer. The tab goes down into a notch in the stator support. We have two sealing rings, they're butt cut. Then we have a race that goes down on top of the stator support first. And then we have a thrust bearing with the needle bearing face downward. One of the things we noticed on the pump gear is that there's no bevel or root chamfer edge found on any of either side of any of the pump gears. Now, the 460 gears measured about 475 thousandths in height, while both the 465 and the 68RC measured about 510 thousandths. The outside diameter that we found in all three pumps was the same. Now in the case we have three more accumulators. The first one that you're looking at here, this is the neutral to drive or reverse accumulator. It has a little step inside. If you look down there inside the accumulator piston itself, you see it's got a step. And of course the linear solenoid D accumulator C is a smaller diameter than the others. Now out of the three, the accumulator A, when all three are put into the case, the accumulator A will extend above the case just a little bit. Again, spring colors and dimension can vary from model to model. We also have the case air checks. Now the factory recommends that when you're doing air check, for the clutch assemblies through the case. We want the regulated shop air down to about 58 to 72 thousandths. Same thing when you're air checking through the pump stator support. They want you to do that. Now there's two clutch pads, the K2 and the K3, that if you're air checking these, they have a 30 thousandths bleed hole in it. Taking some tech calls, the guys will say, look man, I've got a problem with the shift. I think there's a leak in the circuit. You can really hear it, and it's true. When you air check this, it'll sound like it's leaking very, very bad. But that's normal. There should be no modifications needed. When we actually put this on a machine and check for hydraulic pressure, it only took about 5 to 7 psi to get the piston to actually come up and clamp the clutch. Now, 30 thousandths bleed hole is not that much of a leak. We'll talk about that a little bit more as we go through the webinar. And there's your front planet loop. That's where the valve body will mount down on top of that, and in the valve body separator plate, there's that orifice to control the oil going through that section. Now, when you're checking clutch travel, we're not talking about the actual end plate, we're talking about how much travel in the clutch. We use a dial indicator to check the clutch travel. Air test being checked no more than 78 psi to compress the clutch, actually being measured. This is the factory method. If you have any other alternate method that you use that will give you the same information or the same measurement, just keep using that. Now the reaction plates are selected in this unit. So the top plates on all these clutch assemblies are supposed to be selected. Now when we talk about overhaul, they'll give you some tips. We began in the back of the case, the extension housing. We installed the B2 brake piston. You can see we've got a snap ring, a return spring, and then the actual aluminum piston with some lip seals on it. You'll notice on the back of the piston in this area here, the actual contour of this is the same as you see here in the case. So really it'll only go in one way, or it should only go in one way. Now once the piston is in, you'll see that there's a lineup. There's a line on the piston as well as you can see right here on the case. So if everything's installed correctly, quick glance down, you can see that it's aligned the way it's supposed to be. Now there's a factory tool to help compress the spring. You could take a RE4, RO1A sun shell. It works great. All you need is a couple of pieces of steel and a threaded rod with some nuts on it. We can actually do that without purchasing the actual tool from the factory. Okay, now that that section is done, we're going to actually talk about going into the back of the case. So we have the B1 brake piston installation. Same thing here. It's very similar to what we just talked about earlier on the extension housing. You can see this protruding areas at the bottom of the piston will actually match with the case. This large opening will go here. The smaller opening will actually go in this area. So we put the piston in, and then we have one thrust bearing. There's also a bleed hole here, about 12 o'clock, with approximately the same size as what we found in the other pistons. This is the clutch layout. We have two snap rings that are going to go in the top. Once we got the piston in place, the thrust bearing, go ahead and put our return spring in, compress that. You can do the same thing here, just get something to go through the case, or if you can put it on a press, whichever way works for you. Once the return spring's in, we have two pressure plates. We noticed that the thicker pressure plate with the rounded edge went down first. Now the thinner pressure plate at the top is selected. And again, the rounded edge on this went up. I found that unusual. Normally a steel or a pressure plate facing the clutch usually has the rounded edge, but I found in all these that we took apart that hadn't been opened up before, that the rounded edge of any of the pressure plates went away from the clutch itself. So once all these are in, we're going to have two snap rings here. So make sure we put both of those in. When you go to put that bottom thicker plate in, notice here too that it also has a letter on it, an ID letter, and that letter also faces up towards the sharper edge. Again, anytime I've seen ID marks on a pressure plate, usually they face away from the clutches. Now in this area of the case, you can see it's built up a little higher here, a little bit less here, but there are some areas that are built up. So you have to make sure that you align the lugs on either side of that. Otherwise the plate won't sit flat and kind of be wobbly in there, and you really won't notice it until you try to put the clutch pads under the end. You'll have an issue with the snap-on. Now, once all the clutches are in, we can obviously check our travel here the same way as before. You can just air check through the case to apply it. And then we have another thruster. Now, on this ring gear hub, we have to spline that down into the clutches, and we found it was easier to go ahead and put the clutches in first because this edge has got a nice bevel to it. This edge is much sharper. So if we put that in first and tried to spline the clutches over, it was a little more difficult. It was much easier to do it this way. Now after that's in there, we're going to go ahead and put in the middle planet. The middle ring gear goes first, and another thrust bearing. Put the middle planet down in there, and then we have a selective shim that goes on top of that. Now one of the things we want to point out is make sure you take a good look at these planets. Now this one actually came out of the small A460, and this thing was hammered pretty much on all the lugs all the way around. I know some shops probably tried welding that and grinding it down flat, or whatever works for you is fine. But I did notice it's kind of a soft material for a heavy-duty unit, and it seemed to, this one here had about probably, I think, 90 to 100,000 miles on it. Okay, now we're going to go ahead and put in the rear clamp, another thrust bearing on top of that. And then we have our selected race and a thrust bearing that goes in underneath that sun gear shaft. And then we have another race and thrust bearing with the bearing facing down towards the race. And don't forget, this does have a small butt cut type sealing ring here. This one was orange. I've seen some other models. I don't know if it had to do with size or different models, but the sealing ring was a darker color. Now we can install the rear planet ring gear, which is also the B2 clutch hub, and the low sprag list. It's all one assembly. There's a bearing that goes on top of that also. Now, if you have to take this apart, if you actually remove the ring gear from the race, for whatever reasons, make sure that when you do put it back, there's longer lugs that actually go towards the snap ring. You can see that there's a groove here that looks like it'll hold the snap ring also, but basically the longer lugs go towards the race. Now, the slides of this are ramped really nice on both sides, so you can go ahead and put it in now, and when you go ahead and put the clutches in, the B2 clutches will slide right over the spine real easy. And this is the B2 clutch pack. That's why it was important to have that second snap ring here. If that's left out, it's going to throw the clearance way off. So we want to make sure that we have the snap ring down holding on top of the pressure plate, and then right above it there's another snap ring. And that second snap ring is for this pressure plate to sit down onto. We found both pressure plates to be the same thickness in this clutch pack on most of the ones that we took apart. Now you have to go ahead and put the extension housing on, a couple of bolts, air check the B2 clutch, and check your clutch clearance here. Now, although these units have an input and output speed sensor, the vehicle speed signal is gear driven on some models. We do not find that on Ford, on Dodge rather. So some of the import models we did see is gear driven and speed sensitive. Okay, now once the back end is finished, after we air check the clutches, we can go ahead and install the low brake sprag and the output shaft assembly and the speedo gear. Again, it is not gear, it's non-gear driven on the Dodge. What you'll have here, like I'm showing you here on the right, you'll have a spacer instead of the gear. Now, if this is a four-wheel drive, there'll be an added washer in this location. And it don't matter which way we put the gear on, because it is splined at both ends. As you can see, there's only a short spline here for it to catch on to. So added washer first if it's four-wheel, but it always gets a washer on the top. Now once you put the sprag in there, you're going to want to make sure that the sprag legs are either aligned with the 9 o'clock and 6 o'clock, or 12 and 9 and 3 rather, or 12 and 6, whichever is easier for you. But it has to be lined up that way so that these openings are in the correct location for the legs of the piston to get down in there. Otherwise, you won't be able to get the extension housing down on top of it. Now on the bench, if you want to check the sprag, we actually hold the clutch hub and we put the sprag down on top of it. It will rotate clockwise. If you do disassemble the sprag, just remember that with it facing up, as you see here, that we want to make sure that the little windows face towards the left when we put the sprag element back on inside the outer race. You can check again if you like once it's in place. If you want to turn the planet, just make sure that the planet turns counterclockwise once it's in the case. Now we can actually start rebuilding the front case section. And we want to go ahead and assemble the K3 clutch, the pressure plate selective. I didn't find any waved or bevel steels in this unit. And then we have a balanced piston that's made of aluminum. And then our return spring and apply piston. We give you the clutch clearance information also in the handout. Now these were the pistons that I mentioned earlier that have that 30 thousandths bleed hole. It's not very big. And again, when you go ahead and air check this, you're going to think it's leaking too much. If that's normal, you don't need to do any modifications. Like I said before, we hydraulically pressure tested these drums with 5 to 7 psi. It wasn't the holding pressure, but it was that little bit of pressure is all it took to actually clamp the clutch down. Now a 3,000th hole is only going to lose about 4 psi of pressure. So if I've got 80 to 100 pounds of pressure holding this going down the road, I'm not going to worry about that bleed hole. Now someone actually went in, and you can see on this piston, they staked a check ball in that hole. I don't recommend it. If it's something you want to do and it does work for you, that's fine. But it is not recommended to do that. That is a bleed hole when the clutch is released. Now once the clutch is done, we go ahead and put our thrust bearing down inside the case here. And then you can see we have 2 sealing rings, and then we can put the K3 clutch drum down inside. To make sure that when it's all the way down in there, just double check by looking at the splines on the drum and the splines on the B1 ring gear hub. You'll see that they're flush. If they're not flush, it's not down all the way. Now the next item that's going to go in is the front planet assembly. It has a molded piston oil dam for lube here. I suggest taking the snap ring out, removing this, because I'm sure you're going to find a lot of debris maybe actually down hidden in here. It's not uncommon to get one of these in your shop and find some of the bearings missing, find them damaged. This is a heavy duty unit. Again, this is the feed hole. As we talked about earlier, the secondary reg valve feeds it on the 460. Normal lube oil is fed through there on all the other units. So here's the exact layout of how this would go down in there. First we put the thrust bearing, then our front ring gear, then another thrust bearing, and then we put the planet support in. There's 2 bolts to hold it. This is the bottom side of the actual ring gear I'm showing you here. Now this snap ring has 2 bent edges on it. This is the snap ring that holds the molded loop band piston here. Now, putting this assembly together, those snap rings have to align here off to the side. So we found it much easier to take the PTO cover off so we could actually get to them if we needed to from the side of the case. Here's just another look at that. You see through the case here, and then also when we had the cover off, again, much easier to get to that snap ring. Now once that's all in place, the next thing that we have to put in is the front sun gear or the PTO gear. And you can see there's a thrust bearing that goes in there also. After that, we need the K2 clutch hub and shell. That will just slide down in and look like that when it's finished. One of the things I want to point out, these get damaged all the time. This is another metal that's going to be too soft for the application that they're using it for. So if you have a shell that looks like this, it'll have to be replaced. Next, we're going to assemble the K1 clutch. Again, I did not find any waved or beveled plates here. Everything is pretty much flat. And we have a balance piston, and this is a molded balance piston. The apply piston is made of aluminum. We have 4 cylinders and a butt cut for the input shaft, plus there's a cylinder at the tip for lockup. And then we have another race and bearing there. We have the clutch clearances in your handout material. So we would go ahead and drop the K1 clutch hub in to the case. Our thrust bearing, put our drum assembly down in, spline the clutches to the hub, and we should be all set. Now, we assemble the K3 clutch, and we noticed that the K2 and the K3 frictions were the same in thickness, diameter, and the same clutch pattern. Now, you can see here that the drum, the K3 drum, actually splines right into the K1 drum. So if I set the drum on top of that and try to put it all in at once, what ends up happening is this outer edge of the drum and the clutches have to spline onto the K3 clutch hub, and then the front sun gear has also got some lobes on it for that drum. This is what I'm talking about. The drum actually has to spline onto the sun gear, and then we have to get the clutches to spline onto that, and then we'd have to try to get this spline to spline with the forward drum. It's a little bit difficult to do it by already putting the drum on there. So put the forward drum in first, then take the K2 drum and try to work it in. Just like we're showing you here. Then once that's done, you get it all the way down inside the case, then we can go ahead and put the pump assembly on. Now, just as a thought, this is something that we actually wanted to try. If we wanted to lift the case and set it down on this, we wanted to try it. We thought maybe it was too heavy, but actually it wasn't that heavy that it couldn't be done. So we actually assembled the front section all the way up to the sun gear, right there on the pump itself. Now all we did was lift the case, put it on top of it, and then through the window where the PTO gear is, all we had to do was turn the sun gear to get it to spline into the planet, and everything went fine. So it's something you may want to try. So looking at all the component locations, again, we have the extension housing. This would be an exploded view of the entire unit to the rear of the case. And obviously we have an exploded view of all the parts and how they would go into the front of the case. Let's talk about some problems here that we've run into. Now, some of these filters are pretty expensive for these units. It can be as much as $100. So be careful when you're choosing any aftermarket alternative. This is an aftermarket alternative, as you can see here. The element, the filter media, actually got sucked up into the pump inlet. Now, if your customer drives this vehicle and this happens, and he keeps accelerating to try to get off the road when it stops moving, obviously he's going to damage the transmission that you have a warranty on. But be careful where you buy your filters. We've seen a lot of K2 clutch failure. This is very similar to what we've seen in Allison. The stator shaft itself will actually turn inside the support. Now, when that happens, the K2 clutch will drag on first and fourth when it's not supposed to. It also restricts the TCC circuit, causes overheat issues. Now, some guys are having the stator shaft removed at a machine shop, and they're having a keyway actually machined in this area that you see here. That's totally up to you. Now, as we mentioned in the previous webinar, the pump is sold with the valve body for approximately $3,500 due to updates and calibrations to the valve body and obviously to the stator. So again, if you want to try to get it machined, that's fine. If not, that's usually about the cost of a new one with the valve body. This is another thing we see quite often. Notice that this is the input shaft. The stator shaft's completely broke off. And this is usually happens when the computer has been updated with some kind of aftermarket software to get more torque out of the engine. Now, these guys can go to any parts supplier, local parts supplier, and they can buy the tool to install the software and remove it. Even when they bring it back to you, they can remove the software out of the computer. This is a problem we ran into recently. The correct way to install this is on the left. The washer goes on the top, not on the bottom. If you put it the wrong way, basically what happens is this edge of the part ball will actually rub here. So that when you put the extension housing down on it, this will rub on this area. Now, it will not be difficult to put the shifter in park at all. This will move very easily. You can even reach into the case and move it by hand. But the problem is the spring on there is very weak. So when you remove the rod out of park, the actual pawl will stay there and keep the vehicle in park. So you may get a ratcheting noise or just may lock up altogether. So this is a common problem. Try not to make that mistake. And this is actually the factory manual, which shows you the correct way to put this together with the washer at the top. Now, we've shown this in past ATRA seminars and gear articles, but we seem to be getting quite a few calls lately on this mistake, so we just wanted to mention it again here in this webinar. Another problem we have is we see that the flywheel is actually showing up in shop to the complaint of it hitting the engine block. Now, obviously, we have to replace the flywheel or the flex plate and the converter. Always check the bore and the crankcase where the converter pilot fits for any wear or damage. Now, some aftermarket converter suppliers are replacing the original pilot with a much more heavy-duty pilot, as you see here on the right. This is the only fix that we've heard of so far. If anybody's heard of anything different, by all means, let me know. That about does it for today's presentation, sponsored by Seal Aftermarket. If you have any questions, I'll hang on a little longer for you to text them in. If not, hope I see you at the next webinar. Thanks again. I really appreciate your time.